So I actually have two slide decks. The first one is actually the lecture notes I use for my Fang graduate course, social insurance. And then the second part will be a working paper that we are revising for a journal. Also touching on the impact of social insurance in the labor market, but focusing on how social insurance extension might affect unionization in the labor market. Okay, so in the last couple of days, last week or so, you have seen many methods, and this is more applications of the kind of equilibrium structural models in evaluating public policy, okay, through the lens of general equilibrium model, basically, okay. So the policies we'll be thinking about are social insurance policies, right? What are social insurance policies? You must have heard of things like Social Security or universal health insurance, right? So these are insurance programs that government provides to everyone in the economy, paid for by taxation. So it's not individuals decide whether they want to buy health insurance or not. It's everyone that gets health insurance, but the payment for the insurance is going to be financed by taxes. Okay. So the first question we may be asking, so I will start off with a little bit of kind of background, right? So why should government get involved in providing health insurance at all? Why didn't we treat health insurance just like any other commodity market? Right? The government doesn't provide iPhones for you, for example. Why does the government provide health insurance through a social means, right? And the answer is, of course, the market. Like social insurance is a market with that's subject to lots of market failure, right? Adverse selection being one of these, and also health insurance have a lot of positive externalities, right? So the vivid illustration of that may be during COVID, right? So whether the public health is affected not just by whether you get vaccination or not, whether you take precautions or not, it also is affected by what others in the society take preventive measures or not. Okay, so these kind of externalities also in the health market also kind of justify some degree of government intervention. But the question then is, what if the government were to get involved in the health insurance market or healthcare market? How should it get involved? Right. One method is we said is basically public provision. Right. So some countries, in most of OECD countries, the government gets involved in health insurance market through universal health insurance or national health insurance system. Right. So but in some other countries, US being one of the main examples, the government actually doesn't provide national health insurance. Most of the workers get insurance from their employers. The retirees, the elderly people older than 65, they get insurance through Medicare, which is a public insurance paid for by Medicare taxes. Okay. So the first paper I will discuss is a very reduced form, kind of. Later we'll be talking about structural models, but before we talk about the values of structural models, maybe you will see what people were doing before estimating structural model. Right. So this is a paper by in the American Economic Review. By actually, so this I already mentioned 3 options for the government, right? Not getting involved in health insurance market, or it could get involved by mandated benefits. I'll explain what that means, or by the means of tax finance public provision of healthcare. This is what I meant by public provision of health insurance without the national health insurance. Right, so whether you are working or not doesn't matter. You will get health insurance paid for by taxes collected from employers or from workers. Okay, tax finance provision of health insurance. Then the second one, mandated benefits, is actually asking the employers, requiring the employers provide health insurance to the workers, but only workers. right? So that's actually the Obamacare or the Affordable Care Act is an example of mandated benefits. Through Affordable Care Act, that's a law passed in the United States, the US government basically says, okay, all the employers would have to provide health insurance to the workers. But only workers. If you don't have a job, then you don't necessarily get a health insurance. Okay? So that's a mandated benefit. So the question is, let me skip this, I already mentioned. How do you analyze the welfare effects of the three options? One is government do not get involved in health insurance. The second one is government get involved, but not through public insurance provision, but through mandated benefits. Workers who, employers are required to provide health insurance to their workers, paid for, of course, by the firm. Okay. The third option is public provision, paid for by taxes collected from the employer. So the graphical illustration of this the market, free market without employer sponsored health insurance is basically a demand curve, labor demand curve downward sloping. That's coming from firms' problem. Firms are deciding how much labor to demand given the wages. Okay, that's a downward sloping curve, and the workers have upward sloping labor supply curve, and this point A is the labor market equilibrium without employer-sponsored health insurance. Okay, and this is the quantity of labor being equilibrium level of labor demand or labor supply in the free market equilibrium. Now, what happens if the government were to introduce a public provision paid for by an employer tax? Okay, so what does that mean, right? So now everybody actually, or the labor supply curve will not be affected. How is the labor supply curve being determined? Right? Labor supply curve, is telling the workers how much labor they are willing to supply for different levels of wage. Now, public provision is saying, doesn't matter whether you're working or not, you will get health insurance, right? So how many hours are you willing to work in this, simple graphic illustration is not affected under the public provision of health insurance is not affected because whether you work or not does not affect whether you will get health insurance. Okay, that's because it's public insurance. But the labor demand curve is going to be shifted downward. Okay, so B is the B is say how much health benefit what's the level of benefit that workers get from getting the insurance, right? And the firm would have to pay the taxes to finance this insurance that will cover everyone, regardless of whether they're working or not. So the labor demand curve, right? The real cost for the firm is not just the wage they pay for the worker; it's wage plus the tau, right? So the labor demand curve will shift downward parallel by a level equal to B. Okay, and this is the new equilibrium of the labor market with public provision of health insurance. And this triangle is a deadweight loss created by the public health insurance in the sense that there will be workers who benefits from health insurance less than the taxes they will have to pay. They don't pay taxes, but less than the wages they will have to, because initially the wages were here with the health insurance, with the public health insurance, the wages level will be here. So they suffer a wage loss given by this, right? If their benefit level is lower than the benefit they get from the insurance is lower than the wage reduction, they will, these workers are basically, these workers getting insurance actually is a social loss, okay? So this is a deadweight loss from public provision. Now, what if the government gets involved through employment mandate? So the difference, this is actually a paper by Larry Summers in AER in the 1980s, right? This is going to be just a background of what we will do later, right? Before when we estimate structural model. But here, when the government were to get involved through mandated employer benefits, the labor demand curve will still shift downward by P. Okay, because the employers, this is employment. The employer will be asked to pay for the insurance for the workers, only workers stuff. Okay, now the labor supply curve. You see, in the early case, labor supply curve does not get affected when you have public insurance. The reason it doesn't get affected is that whether you get insurance or not does not depend on whether you work or not, because it's public health insurance. Everyone gets it, even if you're not working. Okay, but in the employer mandate, you only get it if you were to work. That's the key difference between public provision and employer mandate. In the employer mandate case, the workers get insurance, but if you don't work, you don't get insurance from the employer, right? So basically, now the labor demand curve actually will shift out, because part of the value from working in this scenario, if you get employer provided health insurance. In the previous scenario, the getting insurance or not does not depend on whether you work or not. All right, so this is and in this case, you get insurance provided by your employer only if you work. So there is if wage is W here, the effective wage is actually W plus something extra. That actually is how much you value the insurance. Okay, and how much you value the insurance here will assume to be a fraction of the cost of insurance. Some workers may value the insurance less than the cost of paying for the insurance. But in any case, in this employer mandate scenario, the equilibrium of the labor market is this point B. Okay, without in the public insurance scenario, the labor equilibrium is labor market equilibrium is this point T. Okay, and the dead weight loss actually under the employer mandate is smaller. Is this little triangle D prime, D double prime, and A, rather than this T prime, T, and A. Right. So the main point of this summer's article was there is a difference in terms of welfare effects, or whether the government gets involved in the insurance provision through public insurance provision financed by taxes assessed on the firm, available to all the everyone, regardless of whether they work or not, in comparison to another scenario where only workers get insurance from their employers, and the welfare loss is smaller under the employment, like in terms of dead weight loss triangle. D prime, D double prime A is smaller than D prime, T, and A. Okay, and of course, I explained that, but this problem, of course, the employer mandate has another problem, which is that's not resolved, is that the health insurance is only available to workers. It's employment. Only employed workers get insurance from their firm through employer mandate, but unemployed workers still don't get insurance, right? And but anyway, this is all you can do in a reduced form, kind of using graphical illustrations. Did you get a lot of the things you want to know, for example, about the impact of a government health reform is not really available here, cannot be answered through this kind of reduced form models. Okay. So what I will do here is actually, this probably, if you already heard a lot of this, what is the value of doing structural work? So this is not the focus of my lecture today. This is just telling you that without writing down workers' preferences, firms' production functions, it's actually very difficult to know. I mean, these triangles, why are they linear? The labor demand curve, why are they linear? Right? But why is the labor supply curve linear? These are all just for convenience, for illustrative reasons, right? Workers' heterogeneity in terms of their health is nowhere here. You would imagine that people who are unhealthy will value health insurance more. People who are risk averse, the degree of risk aversion will affect the welfare effects of providing health insurance. None of these can show up in these kind of graphical illustrations of the that I just shown you. Okay, so this is the winter school for dynamic structural econometrics. So we're gonna be talking about additional values one can additional questions one can ask with structural models, right? So I'm gonna just have a couple of slides motivating structural approach to policy evaluation. Right. So most of you probably have seen reduced form policy evaluation, right? So when some policy was introduced, you'll find some econometric, identification, source of variation to identify the effects of the policy. Maybe before and after different comparisons, maybe you'll find a control group that's not affected by the policy and do a difference in difference, right? Now, all these things are valuable, but you can only evaluate these policies, the effect of these policies after the policy has been implemented. Right? If you do difference in difference method, you can only evaluate policies, the effects of policies after the policy has been implemented. But if you're an advisor to some government, you may want to know before any policy were introduced, what will be the possible effects of a policy that you are considering. These are called ex-ante policy evaluation. Evaluate the effect of a policy before the policy is introduced. How do you do that? You don't have a post-reform data. How do you do ex-ante policy evaluation? Well, structural approach can work, right? So we did two counterfactors, basically, right? So this is, in my view, the ultimate goal of structural approach to policy evaluation. We will be basically estimating some model using observed data, and the data, observed data will be considered to be generated from some underlying data generating process. The underlying data generating process is just a model you are gonna write down. Okay, the equilibrium of the model you are writing down is the underlying data generating process you are trying to recover from the data you observe. I will illustrate that using my two papers that I will talk about. Okay, so the goal of econometrics, structural econometrics, is really trying to recover the data generating process, which of course depends on the parameters of the model, right? So that we are writing down. Okay. The data generating process in economics, the equilibrium of the market, which is determined by consumer preferences, firms, production technology, and various constraints placed by the decision makers. Could be the consumers, could be the firms, and so on. Okay, and these preferences of the consumers, firms, production technologies, and so on, they are considered to be the deep primitive parameters that will be policy invariant, robust to that are not subject to what we refer to as Lucas critique. Okay, now the policies, right? If you want to introduce evaluate the policy through the lens of the structural model you write down, the effect of policy will be basically affecting the various constraints that the consumers or firms will be facing, right? For example, if the government were to introduce a subsidy, well, that relaxes the budget constraints of the consumers, right? So the consumers' constraints will be affected, right? If the government were to subsidize firms' investment in some new technology, well, the firm's optimization problem will be, the firm's production function is still the same, but firm's profit maximization problem will be affected by the prices, the price of the investment or the cost of the investment, because if the investment was subsidized, right? All these things, if you have estimated the consumer preferences and firm's production technologies, etc., using the pre-reform data, then you can simulate the effect of a candidate policy through resolving the equilibrium of the model with a new set of constraints. And that's basically the gist of the so-called ex-ante policy evaluation. Okay. Okay, so that's it. And if people were to ask you what's the value of structural approach for policy evaluation, one is that you can do ex-ante policy evaluation. Okay. The other one is you can deal with the general equilibrium effects. In some cases, general equilibrium effects is very important. If the example I will show you in a few minutes is the effect of photo cap. Well, photo cap is a nationwide policy that affects every worker, every firm in the US. right? It's one of the most important policy, healthcare reform after the introduction of Medicare. And that type of, policy will have general equilibrium effects, right? So, and structural approach can allow you to deal with the general equilibrium effects. Partial equilibrium, the kind of reduced form method, the general equilibrium effect is formed. Right now, the literature refers to the lack of general equilibrium effects by so-called missing intercept. If you have seen some macro papers looking at, how do you what's in the missing intercept? The missing intercept is where the general equilibrium effects will be hiding, right? If you have general equilibrium effects, it will affect not just the control group, a treatment group, but also affects the control group because it's a general equilibrium. So everyone, even those who are not directly affected by the policy, which are the people in the control group, they are also affected by the general equilibrium effect. So when you evaluate the effects of the policy by comparing treatment to control, you basically cancel out the general equilibrium effect because general equilibrium effects appear both in control and treatment. So the general equilibrium effects is actually missing when you do the reduced form difference in difference way of evaluating policy, right? So, but in a structural approach, the general equilibrium effect is actually one of the policies, one of the outcomes, effects we can simulate, right? The third important kind of advantage of structural approaches, it will allow you to study the mechanisms. It will allow you to know not only what is the punchline of the effects, but also through what mechanisms did these effects emerge, right? So that's kind of, and of course you can do welfare evaluation, not just the effects of on labor supply or on things that it will allow you to say things like how much will the consumers be dissolved, right? So basically, in my view, the structural approach relative to the reduced form approach have 4 key advantages. And when you in the future write papers on this, if people ask you why don't you do a difference, you can say, well, one, the structural approach allow you to do extended policy evaluation. 2, it will allow you to capture general equilibrium effect, quantify general equilibrium effects. It will allow you to understand the mechanisms, and finally, it will allow you to evaluate the welfare. Right? In fact, when you write down a structural model, or you always ask, what counterfactuals would you like to conduct? That's actually and the counterfactual policy you want to conduct must be interesting, must be relevant. Right? If you write down a model and you cannot tell your advisor or explain to your advisor what are the interesting counterfactuals you are thinking about doing after estimating the model, I think you should think harder. Why are you doing the structural approach? Okay, the counterfactual that you could do after the model is estimated is the key should be the key motivation for why you do the structural paper. Okay, so with this, I will move on to 2 papers that I worked on related to the interaction between social insurance reform and the labor market. The first one is actually published in JP 2020, Equilibrium Labor Market Search and Health Insurance Reform. The health insurance reform that motivated our study is the Affordable Care Act, commonly known as the Obamacare. I will explain to you what this reform is, right? So this is biggest reform after 1990 on healthcare in the U.S. after the introduction of Medicare in 1965. So Medicare is the tax-financed public health insurance for the elderly, covering people who are retirees who are older than 65, and it was introduced in 1975. Okay, before the Obamacare, before Affordable Care Act, like I mentioned, in the U.S., the working age population either get insurance from their employers if their employers provide health insurance, or they are poor, they may get Medicaid. Medicaid is a public insurance only for low income. Then a lot of people who are uninsured. Basically, 3 kind of insurance arrangements for the working age population in the U.S. before the ACA were introduced. Get insurance from their employer, have if they were eligible for Medicaid because they are poor, they can get Medicaid, which is the public insurance. And if they are not in either category, you basically are uninsured. and about 16% of the U.S. population were uninsured, did not have health insurance before Affordable Care Act. Now, Affordable Care Act is a piece of legislation that has close to 100 pages kind of document, but we'll summarize the ACA as in one slide. 4 major components. One is called individual mandate. Right, so like I said, before ACA, 16% of the U.S. population did not have health insurance. After ACA, the law requires everyone to demonstrate that they have health insurance coverage. When they file taxes, they have to show proof that they had health insurance coverage in that year. If they don't, then they will have to pay a penalty, which is either $650 or 2.5% of the taxable income, taxable income, right? So whichever is higher, that's the individual penalty. Then there's employment mandate, right? We just talked about mandated benefits. ACA actually introduced employment mandate. Employers, before the ACA, before the ACA, they choose whether they want to provide insurance to their workers. So I work for University of Pennsylvania. It does provide health insurance to all the faculty and staff. So we have our Penn already already satisfied the employment mandate before even ACA requires it. But there were a lot of close to 50% of the U.S. employers, particularly small employers, did not offer insurance to their workers before the ACA. Now the law says if the employer have more than employers that have more than 50 employees after the ACA, they must provide their workers with insurance. Otherwise, they will pay a penalty of pay a fine of $2,000 per worker. Right? That's employment mandate enforced by penalty. Okay, that's two main features of ACA. The third one is a regulation on the health insurance market. Before the ACA, if I did not have insurance, if I'm a working age individual, if my employer doesn't offer health insurance through my workplace, if I wanted to buy insurance, so suppose I'm self-employed, I'm say an artist. I don't work for any employer, so I don't have health insurance. If I'm an artist and before the ACA, if I were to buy insurance from the individual market, the insurance company knows that probably I have some serious health issues. That's why I'm trying to get health insurance. So the insurance firms will be priced, could deny they could do a health checkup on me and say, look, you have some serious health conditions. They can deny my application for health insurance or charge me with a very high premium. That was before ACA. In the ACA, important regulation is that it will require all the insurance companies who sell insurance in the so-called healthcare or health insurance marketplace called health insurance exchange, where uninsured or those employed without insurance can purchase insurance from these exchanges, where premium will be based on community rating, meaning that the premium that an artist will be charged will not depend on the artist's own health. It will be depending on the average, the average health of the community of people who buy insurance in the private market. That's called community rating instead of individual rating. Okay, so that's a regulation that requires. So it means that if you are young and healthy, and I'm old and unhealthy, if we both of us buy insurance from the exchange, our premium cannot be the premium I will be charged will not be so much higher than yours. There's still some difference because you are younger than me. They do allow for some age gradient. Older people can be charged more, but it cannot be older. Within older people, they are also young, healthy, and less healthy. If they have the same age, healthy old and unhealthy old individual will have to be charged the same premium, right? So this called so this is an important regulation, right? And then finally, there's an important premium subsidy provision. subsidies will be provided to individuals and families whose income is between 133 and 400% of federal poverty level. And if the individuals have income below 133% of the federal poverty line, they will receive the free Medicaid. Okay, so this part is actually the current policy discussion. Yesterday, U.S. Congress just voted not to extend the premium subsidy in the ACA, but I should, so people are not, this is the premium subsidy specified in the ACA. Then during COVID, the government, U.S. government extended the premium subsidy further. It's actually remove this 400% threshold. So even people like, when their income is very high, could be eligible to receive subsidy. But that enhanced premium subsidy that was introduced during COVID was supposed to expire in the end of this month. Okay, so, but then, the Republicans did not want to extend it. And the fight was not about this basic premium subsidy. So even though yesterday, the Congress did not approve the enhanced premium subsidy extension, the basic subsidy still exists. Still is part of the law. It will still be provided. Okay, so that's the ACA. Now these are pretty complicated reforms, right? And don't you want to know whether before the policy was introduced, what will be the impact of this policy? But how do you do that? I mean, some people will argue that actually before the ACA was introduced to the U.S. as a whole, Massachusetts had something called Romney Care. Right? Mitt Romney was the governor of Massachusetts. In Massachusetts, introduced something somewhat similar to Obamacare, but not identical. So some people in the reduced form camp were using kind of, Massachusetts as a way of, trying to assess what will happen to, what will be the impact of the ACA using the experience of Massachusetts, because Massachusetts essentially had Romney Care before Obamacare was introduced. So Massachusetts has both pre-Romney Care data and post-Romney Care data before ACA was introduced. So some people did that. Some research did that, and the papers were published in AEI and so on. But the question, of course, is Massachusetts is not an average state. Massachusetts is actually one of the relatively wealthy, more educated state than a typical U.S. state. Right, so these kind of things, and what you learn from Massachusetts is still valuable. Reading the reduced form is still valuable, but you may still want to know other things. Okay. But moreover, the methods of the papers used in using Massachusetts is reduced form. So the general equivalent effects are not captured, right? The welfare effects are not captured. They often just will be looking at what's the impact of introducing Romney Care on the average health expenditure of individuals for that. But right, things like that. Okay. So we are going to use and moreover, ACA has a very I would say uncertain. Once after the law is passed, there are numerous challenges to ACA. Several components of ACA is already being, so that this part, right, individuals with income below 133% will receive Medicaid. This was actually ruled as unconstitutional by the Supreme Court. So this part is part of the ACA, but it's already the law. The Supreme Court said individual with income below 133% will be receiving Medicaid became strict down by the Supreme Court. Okay, so the ACA then, of course, individual mandate was challenged, and now actually is no longer being enforced. Trump, in the first administration, stopped the ACA. The individual mandate is still part of the law, but the penalty is not being enforced anymore. So if nowadays, if I don't have the health insurance, I cannot show proof of health insurance, I will not satisfy the individual mandate, except that the government says, well, no, we will not assess the penalty on you. So essentially, individual mandate is not being enforced. employer mandate was never enforced, right? And health insurance exchange is still there. Premium subsidy is still there. So now the question is, could the ACA really function well without individual mandate? Without employer mandate, right? What is the way that we often think of these are the individual mandate, employer mandate, and premium subsidy as the three kind of legs of a stool to make health insurance exchange work. Now, basically, these two legs were taken away. The only leg that still stands is the premium subsidy. Okay, so would the ACA, would the insurance exchange still function reasonably well without the other legs? We don't know, right? So it takes some analysis to do that. So before I go into the model, I would just say, well, individuals do want to have insurance. They are risk averse. They face health expenditure risks. Risk averse individuals want to have health insurance if the premium is reasonable, right? And you can get people to buy insurance either by penalizing them if you don't, or you subsidize them. Yeah, it may make the insurance cheaper. So you can use, this is the stick and this is the carrot. You can always use stick or the carrot to get people to buy insurance, especially the young and healthy individuals who will be basically subsidizing the old and less healthy in the insurance market because the community is raising the fund. All right, so the whole thing about ACA is you need to get young people and healthy people to buy insurance from the exchange so that the old doesn't have to face very high premium. But how do you get the young people to buy? You know, when they're healthy, they feel like they may want to take a chance if the premium was too high, right? So that's where the role of premium subsidy comes in, right? Okay. So anyway, this is and then because of all the uncertainty faced by ACA, you want to know, are there better ways are there alternative reforms to the ACA that can even improve upon ACA? ACA is not a final, when a reform is passed, you can always ask, how can you improve upon it, right? So that's we're having a structural model, and the estimated structural model will allow you to conduct alternative reforms that can improve welfare relative to the ACA, right? So anyway, this is the motivating questions of this paper to understand how the healthcare reform will affect health insurance and labor market, right? So you need a model where health insurance and the labor market interact, okay? Will the ACA significantly reduce the uninsured rate? We hope it will, but how much? Okay, and would more employers be offering health insurance to their employees? So you may say, of course, the more employers will be offering health insurance because there is an employer mandate. The only problem is that employer mandate here is size dependent. Employers with more than 50 employees are required to offer health insurance. But the size of the firm is something the firm can choose. The firm may respond to employer mandate by saying, I'm going to hire just 49 workers. All right, so it's not obvious that employer mandate or size-dependent employer mandate may necessarily increase the fraction of employers that offer health insurance. All right, how would the reform affect wages, health of the population, productivity? Right? After all, healthy workers are more productive. So if the workers, as a result of health insurance, ACA become healthier, you may think the productivity of the economy may increase, right? And what will be, how will the employment, or unemployment rate and employer size distribution be affected by the ACA? And what's the impact on total health expenditure and government budget, right? And then, of course, what will happen if some part of the ACA is actually removed? Say, you remove the individual mandate, will the whole thing collapse? Actually, this paper was written before Trump. This paper, a draft of the paper was already finished before Trump removed the individual mandate penalty. When Trump removed the individual mandate penalty, everyone was saying, okay, ACA exchange market is going to collapse. We actually had a simulation showing that removing the individual mandate penalty, as long as the premium subsidy stands, the health insurance exchange will still function, right? I mentioned that employer mandate was never implemented, not by Trump, not by Biden, never enforced. our paper actually show removing removing the employment mandate have no effect. So employment mandate here really doesn't. This component can be completely removed, almost no impact on the equilibrium. Right? That was before. So we did the evaluation. Yeah, I should mention that this paper, the life cycle of this paper, we started working on this paper before ACA was passed as law. Then the publication process in economics with structural model is very long. So, but at the end, the paper went through a couple of revisions, and at some point, it seemed like Obamacare is going to be just repealed. So the paper almost ran the risk of becoming a paper of economic history. Luckily, actually, Senator McCain had cast the decisive vote to not repeal the ACA. So the paper is not a history paper. But anyway, so it's okay. So now let me go to the before I go to the model, I would use this example as a way to think about what are the first order features of the market you are trying to study that you would like to incorporate into your model, right? The world is very complicated. You cannot possibly incorporate everything that you think is relevant in the world, right? The model will become too complicated. You don't get any new insight, any clear insights. But but that's why I said you need to think about what are the first order important features of the market you are studying that you feel like you need to incorporate, right? Then that's a judgment call. What are the first order ones? You decide, right? You need to, a good researcher will have to have a good judgment, a good kind of sense of making this judgment. Okay, so I'm trying to show you that we wanted to have a feature where have a model that can explain some of the first order features of the U.S. labor market before the ACA. So I would say, we need to have an equilibrium model that integrates labor market and health insurance market. Why? Because in the U.S., I mentioned most of the working age population are getting work insurance from their employers. Okay, so in the health insurance and employment decision, they are integrally linked. Many people, and before our paper, there has been a big literature showing something called a job lock, meaning that individuals may decide to work for a firm that he or she did not like to work anymore, only because that firm offers health insurance. So that's what job lock. I got locked into a job, not because I enjoy the job, but because the job provides health insurance. Because without the insurance from the employer, it's very difficult to get insurance from the individual market before the ACA due to adverse selection problems and so on, right? So obviously, the workers' labor market decisions, which firm to work for, will depend on whether that firm offers health insurance, right? So we need this to be integrated, right? Then in the labor market, there's also some very well-known features of the relationship between employer size and wages and worker firm separation rate. So for example, if you before the ACA, these are all data from before the ACA. If you look at firms before the ACA that offer health insurance to their workers versus firms that do not offer health insurance to their workers, you will see that firms that offer health insurance, they have larger firm size. On average, 34 workers. If the firm did not offer health insurance, only 9 workers, right? And interestingly, the firm that offers health insurance also pays higher wages. 30,000 relative to in contrast to 20,000, and the firm workers working for firms that offer health insurance, they have somewhat lower annual separation rates. They are more likely to stay with their firm, right? Now, surprisingly, if you look at the average health of workers working in the firm that offer health insurance, they are healthy, right? So that this is, of course, most of the workers are healthy. These are, so that in the data we have 5 categories of health. So healthy is referring to excellent or very good health. excellent, very good, and good, three categories. Right? They are all the three have very good health, good health, very good health, and excellent health. And then you have fair and poor. Fair and poor are considered to be unhealthy. Good, very good, and excellent are considered to be healthy. And you can see that average work among firms that offer health insurance, 95.4% reported excellent, very good, or good health. Among those workers working for firms that do not offer health insurance, somewhat lower, 33.89%, right? Small differences in terms of the fraction healthy, but if you look at the complement of these numbers, the fraction that report unhealthy, right? The workers working in no health firms without health insurance are much more likely to be unhealthy. Right? So this actually is somewhat surprising, right? If you think about adverse selection, you may think that the workers that are working for firms that offer health insurance should be less healthy. It's not it's not like that in the data. So we want to have a model to be able to explain all these features in the labor market, including this feature that workers working for a firm that offers health insurance tend to be healthier than workers in a firm that do not offer health insurance. How can you achieve this? Well, the way to achieve this health ranking is a dynamic model, right? Maybe among the new workers, a new worker who's unhealthy is more likely to work for a firm that offers health insurance, because that's adverse selection. If I'm unhealthy, health insurance is more valuable to me, so I would like to work for the firm that offers health insurance if I'm unhealthy. But in a dynamic model, health evolves. If I enter my firm being unhealthy, but if my firm offers health insurance, next period I may become healthy. And if I become healthy and working for a firm that offers health insurance, I may not quit as often. Then in the dynamic model, you can the average worker health in the firms that offer health insurance is some kind of weighted average of the health of new workers and existing workers. Existing workers, even if the new workers enter the firm with a health insurance being somewhat unhealthy, they have positive health effect of health insurance, may quickly overcome the initial adverse selection. And that's exactly how we are going to explain this ranking, right? Okay, so with all this, and also another thing I should mention, the firm size, right? Firm size, the larger firms are more likely to offer health insurance, but also they have higher wages, right? Health insurance is costly. They are, normally when in labor economics, there's this theory of compensating a differential, right? A worker can be paid either in the form of health insurance or wage. If the firm offers you health insurance, maybe the wage will be lower. Not like that. And the data is firms that offer health insurance to the workers also pay more. So that requires a model, us to have a model where firms are actually heterogeneous in productivity. Right? So all these considerations in the data, before you start a structural model, you really have to know what are the major features of the data that you feel that you have to explain. Otherwise, the results you get from a model that couldn't explain some main feature of the data may not be very credible. You have a question.
I mean, the firms who provide health insurance may also prefer to select the applicants who are healthier than so that they reported health to which one will be.
Okay, you mean the firm can may select on health, right? Yeah. So the law actually requires that firms cannot discriminate workers based on health. I will explain. Yeah. So that type of firm selection, firm would like only offer a job to workers who are healthy, that will be illegal. Okay.
Okay.
Yeah.
You have until 10:30.
10:30. Okay. So I'm gonna go to the model now. A simpler model than the one that's actually in the final version of the paper. We're gonna focus on working age population with low education. Because, for the higher education, people with PhD, almost all of them have worked for employers with that offers health insurance. So ACA was not really for people with a college or postgraduate degree, right? It's for relatively less educated workers. So we'll be focusing on less educated workers, and so they are exactly homogeneous except for health. Okay, they are risk averse because we're talking about health insurance. So we would like them to be risk averse. Their health status could be healthy or unhealthy. In the model could handle any finite health category, but for the purpose of illustration, we just have healthy and unhealthy. The workers' health insurance could be uninsured or insured. Health insurance have two effects. It insures the workers on their medical expenditure charge. And the second, it affects the law of motion for health status. If you and I both have the same health status today, if you have health insurance, I don't, next period you are more likely to be healthy than I do. Because you have health insurance, you may be able to see the doctor more often and so on. Okay. Health insurance in this model is only available through employers. In the published version, we will also have Medicaid. We also have possibility of getting health insurance from my spouse's employer and so on, but not in the presentation today. Now, firms are competing for workers, right, by offering a combination of wage and health insurance. So typically, we have in the labor market model, we have firms compete for workers only through wages. But now, since we are allowing the firms to decide whether to offer health insurance to their workers or not, this combination, wage and health insurance provision, that's called the compensation package, is how the firms are going to compete for workers. Okay, a combination. Okay. And the firms are heterogeneous with respect to productivity. This is key to explain this fact that firms offer health insurance also pay workers higher wages. In other words, in the end, in the equilibrium of the model, firms with higher productivity are more likely to offer health insurance to their workers, and at the same time, they are more likely to pay higher wages. Production technology is linear with labor inputs. If a firm has productivity P, the firm hires N healthy workers, that these N workers will produce N times P units of output. If the worker is unhealthy, then the worker doesn't get to produce the entirety of P, just only will be able to produce a D fraction of P. So if the worker is unhealthy, he got sick, he will be absent from work for 1 D fraction of the time. So even though the firm productivity P, a healthy worker is only be able to produce D times P. Okay, so investing in the worker's health is actually can improve firm's productivity. Okay, so now this is the real question, right? Choosing wage and health insurance coverage. The firm choose wage and health insurance coverage to maximize the steady state profit flow, subject to the constraint that all workers in the same firm are equally treated. They cannot distinguish. The firm cannot just say, look, if you're unhealthy, you don't get the health insurance, or you don't or you get a different wage. That kind of discrimination will not be legal due to the law known as HIPAA, the Health Insurance Portability Act. That's the law that prohibits firms from discriminating workers based on their health. Okay, the offering health insurance is costly. A firm offers health insurance. The firm must cover the total expected medical expenditure of all the workers plus some administrative costs. Okay, so that's the model, right? And the model is very simple. Workers, right? They have some preference as risk averse. There's some health status. They like health insurance, but they value health insurance because they are risk averse. These are the worker side, and firm side. They have the production technology. There is the cost of providing health insurance and so on, right? So so far I don't have symbols, but you can put these mathematical expressions. Utility function is absolute constant risk conversion. health status is at little h, health insurance status is X, which is 0 or 1, no insurance or insurance. Medical expenditure is random. Because this is again motivated by what the literature knows about the medical expenditure distribution. The medical expenditure has a big mass on zero. A lot of people spend $0 on health expenditure in a given year, a big mass. But conditional on having a positive expenditure, this is the probability of having any positive expenditure, right? The complement of this is the probability of zero expenditure. Conditional on having a medical expenditure shock, the distribution is given by some log normal, right? So the mean of the medical expenditure distribution will be higher if you're unhealthy. Will be higher it may be higher if you have health insurance. Catherine Moore has the effect of health insurance. If you have health insurance, you're more likely to see doctors even with a little cold, right? So that's the more has the effect of health insurance. This is just the health effect of health expenditure. Unhealthy guys are more likely to have shots. And then these are the variances, the randomness in health expenditure, and the randomness is what leads the demand for health insurance for the risk-averse workers. And this is how we capture the impact of health insurance on health evolution, right? So health could be transitioned from healthy to unhealthy. Healthy this period, there's some probability you'll remain healthy next period. That's pi HH. But pi HH depends on whether you have health insurance or not, right? Pi UU also depends on whether you have health insurance or not, right? So basically, here we are saying pi 1 HH, for example, is higher than pi 0 HH. If you don't have health insurance, you may less likely to remain healthy than if you have health insurance. These parameters will be estimated using the data, right? So and then the flow utility workers are risk averse as a function of the after-tax income. So we also capture the tax schedule, right? In the U.S., the government exempts the health insurance premium from income taxation, and a lot of people were interested in understanding what if the U.S. government were to remove the tax exemption of health insurance premium. In order to evaluate such a counterfactual policy, you need to have the tax schedule being part of the model. Without the tax schedule, then you cannot evaluate an interesting policy, which is remove the tax exemption or include the health insurance premium paid for by the employer into the taxable income of the worker, right? So what kind of policy evaluation can you conduct depends on what features you include in the model, right? So since we're interested in that tax exemption counterfactual, we incorporate this tax schedule. Okay, so I'm gonna of course, you write down the workers problem. Workers can be either unemployed or employed. If you have unemployed, the workers will be, it's a labor market with random search. If I'm an unemployed worker, I randomly get matched with some firm that may or may not offer health insurance, and with some wage and health insurance packages, right? Then I decide, given my health, do I want to accept this offer? If I decide to accept the offer, then I become unemployed, but I can continue looking for jobs. There's on the job search. So if I may start out working for a low wage without health insurance in McDonald's, but I'm not satisfied there. I may continue searching another job while working for this low paid job in McDonald's. Then I may get a better offer than if I do, I move. It may even happen that I started working for a firm with a high wage, but no insurance because I was healthy at that time. Then I got a negative health plan. Then I really want to get a health insurance. I may decide to switch to a firm that pays low wages, but offers health insurance. Right? There are a lot of interesting labor market dynamics that these models can generate. Okay, and the model's parameters will be estimated by matching the model's prediction of different kind of labor market transition path implied by the model under different parameters of the model with the data, right? The corresponding transition patterns and data. So I'm going to skip some of that. We'll interpret the pre-ACA labor market data as being generated by the steady state equilibrium of this complicated model, right? So workers will all be working for some firms, and they are all transitioning in different jobs, but in the aggregate, the distribution of workers of different health at the different firms, they are stationary. That's, I mean, I'm gonna I don't have time to go through all that, but and this is the definition of the equilibrium. Importantly, the distribution of workers firms that offer the wage distribution of firms that also offers health insurance, the wage distribution of firms that do not offer health insurance, they are all endogenously determined by the firm's optimal decision, right? When the government started to introduce the ACA, the individual mandate, employer mandate, and so on, the firms will re-optimize in response to the new policy, as captured by the ACA. Then the whole equilibrium of the labor market will change. The distribution of the wage given health insurance, wage without health insurance will also be affected, right? So we can talk about all that in this structural model, but I'm gonna, so only 30 minutes left, right?
Yes.
Okay. So before I even show you some counterfactuals, I will basically try to reconcile one thing: why are larger firms more likely to offer health insurance? That's where I think some of the very interesting economics shows up. Okay, so first of all, you can think about firms in the economy. Some of the firms have low productivity, and some of the firms have high productivity. In this simulation, the low productivity firms are the firms with the bottom 20% of the productivity in our model. The high productivity firms are the firms with the top 20% of the productivity in our model. Okay. We show that if in the steady state, if a low productivity firm, a firm with the bottom 20% of the productivity distribution, were to offer health insurance, the fraction of workers that are unhealthy in the steady state will be about 5%. Okay, unhealthy. Okay, but if you're a high productivity firm and offer health insurance, the fraction of unhealthy will be only 3.7%. In other words, the high productivity firms are much less subject to adverse selection than the low productivity firms if they were to offer health insurance. Why is that? Right, that's the key thing. This is consistent with the feature we show in our model, right? The firms that offer health insurance also have lower fraction of unhealthy workers in the steady state. I showed you that was a puzzling fact, right? So it turns out that among the new hires, right? If you're a low productivity firm and when you offer health insurance, you do attract a higher fraction of unhealthy, 8% relative to 7.4%. If you're a high productivity firm and offer health insurance among the new hires, you see the adverse selection is also there, 5.1. If you offer health insurance, relative if you don't offer health insurance among the new hires. But you see the adverse selection for the high productivity firm is only very tiny. Here is more significant. Now the question is why? Okay, so the key difference is that the new hires, if you are low productivity, if you're McDonald's, a low productivity firm, where are the new hires into McDonald's coming from? They are coming from unemployed or even a firm that are even lower productivity, who typically do not offer health insurance. So in other words, McDonald's potential new hire are mostly coming from people who do not have health insurance. If you are Google, who are the new hires of Google? They include some who are from unemployed, but also a lot of them are actually job-to-job switchers who were working for some other firm that are not as productive as Google, but still quite productive. And they were, offered health insurance before that switching to Google, right? So in other words, the potential pool of new hires that Google, the high productive firms are drawing from, is a different pool than the low productive firms are drawing from in terms of new hires, right? McDonald's can only attract people from unemployed or workers working for firms that are less productive than McDonald's. If you're a high productive firm, you are attracting workers from unemployed, but also any other firm with lower productivity than yours, right? Which includes many productive ones, right? And these productive firms will offer health insurance in equilibrium, so their workers tend to be healthier. So the overall pool of new hires that high productive firms are going into are not as adversely selected as if they don't offer health insurance. Yeah.
So as the same, I think maybe the same story in China state of company.
Yeah.
It's the big company, even though they are not the high productivity firms, but they are big firm and they will attract more high skilled and high quality workers to the big to state firms. So
Yeah.
they are naturally more healthy.
More healthy, yeah. So this is so in other words, adverse selection problem is there. It's just not as pronounced for the high productive firms than is for the low productive firms, right? So that is one reason for the high productive firms to be more willing to offer health insurance because they are less subject to adverse selection problem. Secondly, if you're a high productive firm, you offer health insurance to the workers become healthier. Healthier workers are more productive. But then you are also, the high productive firms are also more likely to retain these high productive, healthy workers. Well, if you already work for Google, what other firms can you switch to? Very few. If you work for McDonald's, the moment you get another job, you leave. So the health effect of health insurance, right? The positive effect of health insurance on health, on improving health, that benefit is more likely to be reaped by the high productive firms than for low productive firms. Like if McDonald's were to offer health insurance to their workers, the workers become healthier. That worker would have been more productive if the worker continued to work for McDonald's, except that that worker will be very easily attracted away by any other firm, right? But if you are already working for Google, very few firms with even higher productivity than Google. So your workers, you invest in that worker's health in Google, that worker will be almost surely continue to work for Google when the health is improved by the health insurance offering, right? So that's the retention effect. Retention effect, you see, the high productive firms, the workers don't leave. So if the high productive firms can invest in the workers' health by offering health insurance, and that health benefit of offering health insurance will continue to stay within the firm, making the firm more productive, right? Because healthy workers are more productive. If you are a low productive firm, the moment the workers become healthy, they leave. So that benefit of improved health does not stay with the low productive firm because they have so very high. Okay, so that being said, I'm gonna, we estimate the model, then I will do some counterfactual here. Okay. The firm's productivity P is static, but the workers, the worker's health is dynamic, is evolving, right? So a healthy worker working for a firm with productivity P produce P units of output. Unhealthy worker produce only D times P. D is a fraction of less than 1, right? D times P of the output. The firms, but the fraction of workers who are unhealthy is affected by whether the firm offers health insurance to the workers or not, and how likely the worker leave. Right. So in some sense, when the Obamacare was introduced, it will have impact on productivity. by affecting the overall health of the population. If all the most of the people become healthier with Obamacare because more firms are more workers have health insurance, then the aggregate productivity of the economy will improve, even though the productivity of the firms, that distribution does not change. Right? Just population health can improve. Improvement in population health can improve the overall productivity of the economy, even though the distribution of productivity does not change. Okay. Okay. So let me just show you some of the things that one can do. So then that's the baseline model. Then do the counterfactor. We need to introduce the features of the AC, right? So individuals now, right? So this is the employment. Okay, so we will introduce health insurance exchange in the counterfactual for ACA. In the baseline, workers either get insurance from the employer or cannot buy insurance from the market. Now we introduce a market. If I don't have insurance from my employer, I can buy insurance from the exchange, right? With a premium that will be determined in equilibrium, which is 1 plus a loading factor theta times the average medical expenditure of the individuals who are actually buying insurance from the exchange. That's a premium. Okay, but individuals will get subsidies. The out-of-pocket premium will be smaller. Okay, so if you don't buy insurance, you'll face a penalty according to what's being specified in the law. Okay, and if the firms, if the number of workers, the firm size is endogenous in the model, so the penalty is basically according to the law. If you have more than 50 workers and if you don't offer health insurance, you'll pay a penalty equal to N times 2,000, but there is a 30 worker allowance. If you only have 50 workers and you don't offer health insurance, the penalty is not 50 times 2,000, it's 20 times 2,000. That's just what's being written in the law. Then there's premium subsidy formula according to the law, right? So we basically can introduce these 4 features are changing what I mentioned earlier, are changing the various constraints that firms and consumers are facing, right? The consumers now have access to this market. Consumers will pay a penalty if they don't buy health insurance that affects their budget constraints. Firms will face this penalty if they don't offer insurance to their workers, and if they have more than 50 workers, and the firms workers are getting subsidies from the government. Okay, if their income is sufficiently low, then you can resolve the equilibrium, right? And these are some of the results. So the benchmark is the equilibrium of the model without ACA. I'm going to focus on this number. Sorry, the uninsured rate, distribution of health insurance status, uninsured. This is a fraction of individuals in the benchmark that will not have insurance. It's 21.3% before the ACA. With all 4 features of ACA introduced, we resolve the equilibrium model. Only 6.6% of the people will be uninsured. Okay, and how does the uninsured? So that's is something that a reduced form guy using pre and post data might be able to find as well. Okay, the 21.3% uninsured rate is lower to 6.6%. But we can do more, right? We can ask, where does that reduction in uninsured rate come from, right? Part of it is coming from big increase in the individuals buying insurance from the individual insurance market, right? Before the ACA, there's only 3.4% individuals buying insurance from the exchange. The premium is very high, actually. Premium in the exchange, and that will know. Okay, premium was individual insurance was only 3.4%. After the ACA, it went up by 11.2%. Medicaid expansion, right? Increased the insured rate by about 5%. In the model that's in the paper that's published, we also have spousal insurance. So some of the workers get insurance from their spouses, right? And the employer-sponsored health insurance actually declined. You see this surprising result? Despite the employer mandate, the individuals who get insurance from the employer-sponsored health insurance went down from 59.5% to 58%. So this idea that employer mandate may increase health insurance from the employers actually was not true in our simulation. Okay, so that's the ACA. We can also do welfare, workers' utility or firm profit and so on. See, that's the nice thing about the structural model. You can evaluate the welfare. Okay. We can also look at firm size distribution. Distribution of firm size. In the paper we report that. Okay. Now, what if we have the ACA but without individual mandate? What if we have ACA without employer mandate? You see, this is the thing that you can see. The uninsured rate without employer mandate, right? This is the full ACA, 6.6%. Without employer mandate, it only went up by less than 1 percentage point, 0.9%. Right? That's what this was the result was already there before actually. Nobody knew that employer mandate was actually not that crucial. The politicians really thought they needed to have the employer mandate as part of the ACA so that firms don't race to the bottom. We actually know why why employer mandate is not that important, because firms are risk neutral, workers are risk averse. The firm actually can exploit the fact that they are risk neutral and their workers are risk averse to attract workers using health insurance offering. Is actually cheaper way to attract and retain workers. Right, so that shows that the firms are already benefiting from the fact that the offering health insurance is a cheaper way to attract workers than raising wages. So they will the employment is not really the key motivation for the firms to be offering health insurance to their workers. It's just right. So removing the employer mandate does not have big impact. Okay, removing individual mandate will have impact. Right, the uninsured rate will go from 6.6% to 11.4%. But the ACA the insurance exchange did not collapse. So when Trump removed the individual mandate penalty, a lot of people thought the ACA is gone. Right, the no way that insurance exchange will continue functioning. We already knew that it will not collapse as long as the premium subsidy is there. If you were to remove premium subsidy, you see, ACA without premium subsidy, then actually the individual insurance market completely collapses. Nobody is getting insurance from the exchange anymore. It's like the carrot is much more powerful, turns out, than the individual mandate in getting people to buy insurance, getting people from who did not have insurance from the employer to buy insurance from the exchange. Okay, so that was I think these two features, that individual mandate will remove individual mandate will not collapse the insurance exchange. That was actually was surprising exempting. Okay, employer mandate is not that important. That was very surprising. But later on we understood why. And we also knew that premium subsidy is the most important part of the ACA in getting the health insurance exchange to work. Okay. Because the paper went through quite a lengthy review process, we were asked to, we actually were asked to do a comparison of our model's prediction with some kind of early impact of ACA in the data, and I think that the referees were happy that we are getting more or less the model's prediction was kind of lining up with some reduced form kind of estimates in the literature. Then we get counterfactual quasi-experiments of various components of ACA. Suppose we only have the exchange, or only with exchange plus subsidy, exchange plus individual mandate, exchange plus employer mandate, and exchange plus subsidy plus individual mandate, but with no employer-sponsored health insurance for now. We found that employer-sponsored health insurance here and ACA, they will complement, they are working together. Removing employer-sponsored health insurance is actually gonna increase the uninsured rate, right? Okay, so I'm gonna skip this. So anyway, that's an example of how you can use structural model to evaluate an important piece of a labor market reform, a healthcare reform, in an equilibrium model. And I forgot to mention that firm size, for example, is because the ACA has an employer mandate that's size dependent. So you want to know, for example, how would the ACA affect the firm size distribution to the extent that firms may indulgently choose to lower their firm size to be below 50, right? So we can do all these kind of things. Now, another, I only have 10 minutes, but let me just give you another example of something that along the similar spirit, but it's a different model. But let me just actually pose a question. And I will not go to the model, but this is a paper that tries to explain the decline of labor unions in the United States. Labor unions in the United States peaked at about 35% in 1954. Now it's less than 8%. A labor union is, you know what labor unions are, right? They negotiate on behalf of the union workers, better pay, better benefits. Benefits include retirement, health insurance in retirement, unemployment insurance benefit, more job security, and so on, right? So there's a big literature trying to explain why the labor union declined. In this paper, we basically say, look, what the labor union used to negotiate for the workers, they are not being provided by the government. You don't need a union to negotiate for health insurance anymore because the government is saying everyone, regardless of whether you are unionized workers or not, will get insurance from the government, Medicare, or if they are retired, or Medicaid insurance for them, right? So the value of union have been diluted as a result of health insurance. So that's basically what we do, right? The unions may be affected. Unions affects health insurance provision by the firm. That in the reduced form, people already know, right? Freeman and Madoff have shown that unionized workers are more likely to get. I will show you that as well, right? In our days, okay? Unionized workers are more likely to get insurance, receive insurance from their employers and so on. They are more likely to get all sorts of benefits if they are unionized, and they also have better job security. Now, then the second part of the paper is to show. But we don't assume that. We actually, the paper is kind of I'm quite proud of it because we're actually able to have a reason. It would like why unions are more likely to offer this insurance to negotiate these insurance benefits for the unionized workers. We don't assume that. The literature basically documents an empirical relationship between union status and benefit status, but we actually will, through the lens of the equilibrium model, will generate an outcome where when unions bargain with on behalf of unionized workers with the firm, they are more much likely to bargain for the benefits. Then individual workers who are not unionized, what do they do? They will engage with the firms through individual bargaining. And individual bargaining and collective bargaining, right? Unions will be doing collective bargaining. The individual bargaining and collective bargaining, looking at the problem of these two problems, it turns out that in the collective bargaining problem, the outcome is more likely to include these benefits that have some kind of fixed cost than individual bargaining, okay? Then when we do the counterfactual of, okay, what if some of the benefits that the workers, unions were negotiating, were bargaining for the workers, are now provided by to all workers through social insurance. What will be the willingness to join the unions by the workers? And we see that there's a big reduction of unionization. So basically, right. So in the counterfactual analysis, we can ask, when social insurance is expanded, what will happen to the wage inequality through unionization rate? Actually, this is a second one, right? So we show that social insurance expansion can explain a very sizable part of union decline, in addition to the impact of technological changes, skill-based technology changes. So without going through the details, we found that skill-based technology changes from mid-1950s to 2010s accounts for about 35% of decline of labor unions, and the social insurance expansion in that period explains about 17%, about half as important as skill-based technology change, but still very important. Okay. So yeah. So again, this last minute or so, I will just show you again how do we decide what are the important features that you would like to include in the model, right? So in the previous table, we didn't have union. Now, because that was not, of course, the union was always, it was in the previous table, was part of the labor market as well, right? So what features do you include in the model depend on the question you're asking, right? In the previous paper, union is there, but not a key focus on the previous paper. So we don't model union. Here, the key question we want to ask is, what explains the decline of unions? So unions must be part of the model, because that's the question you are trying to ask. You need to do counterfactual impact of some counterfactual experiments that will affect the size of union. Right? So union must be part of the endogenous thing in a paper on union. Right? Then what others do you want to explain? So you want your model to be able to generate, right? So union firms are larger, right? So average established size, if they establish unionized about 100, non-unionized established only 22 workers. Okay, so that's a very robust feature of the labor market. Union firms are larger. Union firms also pay higher wages. Union firms have higher insurance offerings. Okay, so all these features are important, right? So we want the model to be able to explain, right? So the nice thing about, so I will not go, the paper is in my website, on my website, you can take a look if you're interested to learn kind of, how do you, if you're interested in this kind of problems, how do you, I guess the one important thing is, everybody can write very structured models, very complicated structured models. The problem is, the key kind of skill is actually to think about what to simplify and what to improve. You cannot write it, often the model becomes so complicated that you lose insights of what's going on, right? But here, but it's important to make a judgment in terms of what not to abstract away. Okay, so let me show you what's the effect of union on how these are reduced form evidence motivated. So actually, I forgot to mention the literature on that try to explain the decline of union is huge. We are bringing a new feature that has not been incorporated in the literature, right? The expansion of social insurance might reduce the unionization rate. No one in the literature have focused on this connection. So it's then as a paper that try to bring in a new channel, you need to provide through the lens of structural model. It will be useful to motivate why you bring in union in a paper, why you bring in the social insurance expansion as a potential channel for for the union decline by introducing some reduced form evidence to motivate your paper, right? So that's another thing that often people who got used to do it, write structural papers forgot that we in economics actually is in the exercise of persuasion. Right? If you need to persuade the readers, the policymakers, that the potential mechanism you are bringing into in the literature is plausible. it's not far-fetched just because you can write a paper, write a model on it, right? You need to motivate that. I'm not totally crazy to make a connection between social insurance expansion and unit decline, even though the literature has not made that connection before, right? So the first part of the paper, the reduced form evidence, is to make that connect motivation, right? Oh yeah, union firms are more likely to offer employee-sponsored health insurance. They are more likely to offer pension. They are more likely to offer life insurance to their workers, but not so much on long-term care insurance. Then when unions decline, when social insurance expansion, you indeed find some reduced form suggestive evidence that is associated with declining unions. So I will just show you, then I will stop with this one, okay? So we'll use the introduction of Medicare in 1965. I already mentioned 1965, every retiree in the US get insurance coverage through Medicare. It's a social insurance. Before 1965, the retirees with health insurance, almost all of them get this retiree health insurance because they were unionized before the retirement, okay? So basically we have a situation like this. Before 1965, retirees with health insurance, if they are getting that retiree health insurance because they're union. After 1965, everyone gets health insurance, regardless of whether, every retiree gets health insurance, regardless of whether you are unionized or not. So now we have a variation across states in the pre-1965 retiree health insurance rate. Right, so that's for the exposure. If a states have a very high pre-1965 retiree health insurance rate, that is now being diluted by Medicare introduction more than a states where almost no one is getting retiree health insurance. Okay, so larger exposure. So with the prediction is larger exposure as measured by the pre-reform, pre-1965 private retiree health insurance coverage. Right, that's the variation across states. Right, that's exposure as do we see a larger decline of unions in such states? And we find that, right? So in states with higher variation, higher exposure, higher pre-1965 retiree health insurance coverage, these states experience much larger decline of unions, right? So this was just a few kind of there are other things as well, but these are the motivation, evidence that we use to motivate bringing in the social insurance expansion as a potential contributor to the decline of union. But then we write a model and estimate and do counterfactual estimation, but I run out of time. I will stop here, and the slides will be online, and I hope if if you're interested, take a look at the paper and slides. And the key is to learn to have good kind of taste of motivating the structural model using reduced form evidence, making good decisions about what features are first order important to include in the model, while abstracting away some less important features of the reality. Right? That's a delicate balance of not to include everything, but not to throw away the key features is really the art of structural modeling. Okay, so I'll stop here. Thank you.
Thanks so much.